So this is investigating associations between two categorical variables. We're just dealing with the categorical in this topic, and then we're going to move on and start talking about numerical as well. But for now, as we mentioned last lesson, the scatter plots is the obvious bivariate data analysis tool, but that only works for numerical or maybe categorical ordinal. But for categorical, where it's ordinal or nominal, we need to find another way, and this is the other way, and this is going to be a bit loose. So when we're making assessments based on this data, it's not necessarily going to be the strongest assessment. We're going to get to a point now in this topic where we're making statements from the data where we say there is an association, but it's not a definite association. It's not a clear association, but mathematically it looks like there could be an association. So that's where we're heading. And to do that, we're going to use two-way frequency tables or two-way percentage tables. So here's the first example, and it's a survey of people. Don't think it defines age groups, no. And it's split into males and females, and it's just a for or against gun control survey. So this is just an example that's come from the textbook. So you might collect data. There's 3 pieces of data there, and you probably have collected more, as much as you can potentially. But obviously collecting data comes with a couple of issues as well. Time and cost for larger sets can be an issue. We can summarize this data into a two-way table and talk about it from there. So I'm just going to scoot down to here, and then we can talk about, this is just a reminder, the explanatory and the response variable reminder. So we have 2 variables here. Our 2 variables are you male or female, and are you for or against gun control? There are 2 variables. Be careful you read this correctly, because I've seen people with questions like this, and you see gun control and you see for, and then just mix it up in your mind and you start making statements about how many people are for having guns. So gun control and guns are the opposite things. So the response variable, you remember, is the variable that's associated with the outcome. The explanatory variable is the variable that explains the response variable. So they might depend on each other. They might not depend on each other at all. There might be no association, and we can't use one of them to explain the other. But most questions that we give you, there's going to be a clear explanatory variable and a clear response variable. In this case, hopefully you can see that a person's gender is not going to be explained by whether they're for or against gun control, but there is a chance that there might be an association to say that either males or females are more likely to be for gun control. So in this case, potentially, the explanatory variable will be the gender, and the response variable will be attitude to gun control. There's going to be a gap in the video, I'm afraid. Okay, let's talk about creating this table. So here's the data. I know we didn't show all the data earlier, but that would be a fairly big long table. So there are 58 males in the survey, 42 females, 100 people in total. And that data has been collected into what's called a two-way table. So a two-way table has a variable that goes in this direction and a variable that goes in that direction. So it creates 4 or more cells here that represent bivariate data. So for example, this cell here has 26 people in it, and those 26 people are males who are against gun control. So it's creating that. Each number now represents the response on 2 variables, not just one. And that's why it's called a two-way table. So we've got our two-way table there. They're fairly easy to develop and set up, but also a big part of this is one of the 2 graphs that we'll use for this topic, and this is a big topic. So you need to make sure you know how to use two-way tables. We can expand a two-way table to include more information. So here's the expanded version. If you're copying it down, you might want to copy down the expanded version, and it will help us with our understanding. So we've got this orange section in here, which still has the raw data. 32 males are for gun control, 26 are against it, 30 females are for it, 12 are against it, but it also has the totals, which might come in handy because you might get questions that might say something like, what percentage of what percentage of people are females and for gun control? And you would say, well, that's 30 out of 100, 30%. But if the question said, what percentage of females are for gun control, Well, there were 42 females and 30 of them are from gun control. So that would be then a 30 out of 42. And that's where that 42 becomes important. And that's where the wording becomes important as well. The first one was what percentage of people are female and for gun control. And the second one was what percentage of females are for gun control. So I'll show you some examples of that as we move through this topic as well. So you note here, I've just stolen these notes, and I'm going to spend my time working on other resources for you. But here we defined what cells are. So we'll refer to them as cells, and these cells represent where the information goes. Any questions on how those two ways tables work? They're a really good way to represent information. It's fairly simple information, but the step back from this was a list of 100 people and their responses to the two questions. So this is a really good way to represent that overall information so that you can see it and not have just a whole bunch of totals or some big long table. Okay, let's talk quickly about how we could develop percentage tables. The problem we had in the earlier question, and I'm just going to scoot back up again. If you have a look at this table here, it kind of looks a little bit like the same number of females and males are for gun control. In fact, if anything, there's more males that are for gun control. Does that mean that our conclusion should be that males are more for gun control than females? Anybody got an answer to that? Or equivalent? Maybe it's close enough we could say about the same amount of males as females are for gun control. Is that a fair statement? It kind of looks like it, but this diagram is a little bit misleading. So you've got to be a little bit careful with what you're doing, because actually that 32 males are for gun control is out of 58. That represents only a bit over half, whereas the females, 30 out of 42. That represents something more like 75%. So there is actually a difference. Because there were more males surveyed, the pure raw data, the numbers there, aren't a perfect representation of the distribution on how things sit. So this is where we might go down and do a percentage table. And so I might be relying on you here to help me out. There it is. So we're going to calculate some percentages. We want to know what percentage of males are for gun control. It should add up to 100 in the end. So there were 32 males out of 58. 32 divided by 58 times by 100 is 55.17%. And I want you to get used to this. You see how I've got two decimal places here? Some of you didn't do this in the exam. The exam will always state at the front, unless you're otherwise told, two decimal places needs to happen. That means that down here we've got 44.83%. And in the female section, we've got 30 females out of 42 times by 100, and that's 71.43, which leaves us with 28.57% who are against. And these sum up to 100, but now it's a better representation. 32 and 30 made it look like, well, there were more males in the survey than females that were for gun control, but there were also more males in the survey, full stop. So the proportions are only a bit more than 50% of males are for gun control, whereas over 70% of females. That's significant now. And it's a better representation. It means we can evenly compare the two. So that's a percentage thing, and I've got the actual answer from the textbook there, so we can have a look. That's where we got. They've used one decimal place, and so I'm telling you to get used to using two, because you need to in the exam be using two. Are there any questions on that? I know people are writing down, but I'm just going to scoot down to some of this writing here so we can talk about it. So there's stuff here. You could write this down later if you want to, leave a space, you don't have to. But it's a summary of what I've just said. And that is that whilst the comparison without percentages looked like males and females were equivalent for gun control, the comparison with percentages shows you that the females are more for gun control based on the information there. So you just got to be careful, and converting to percentages for your conclusions is often a good way to go, and gives you that opportunity. And I'm sorry if people are still copying down. Here's a conclusion in light blue to make it easy to read. In the sample of 100 people, we see a higher percentage of females were given gun control that makes than males, 71.4 to 55.2. This indicates that the person's attitude to gun control is associated with their sex. So that's where the situation comes in. High percentage is important, so you note there that that's basically giving you units. This is a measurement as a percentage. It'd be the same as saying it's further in meters or it's weighs more in kilograms. It's basically giving units, and it's important to give units because if you don't make that percentage statement, we don't know whether you're talking about the 3230 or the 55.2, 71.4 comparison. It makes a statement that there's clearly a higher percentage, and then it makes a concluding statement based on that there is an association. So what we mean by that is that if I went and just found somebody on the street to ask them whether they were for or against gun control, I would expect it's more likely for them to say yes if they were female. That's what this result's saying, and that's what an association means. There's no association if there's no variation based on the explanatory variable. If they were both 55%, there'd be no association. Okay? Yeah. That's a really good question, and it probably depends on where it sits on a percentage scale. So, for example, if it was 90% of males but 95% of females, you'd probably still say there's an association because that's, even though it's only a small gap, it's right at the top end. And if you flip it around, it means that 5% of females are against, whereas 10% of males are against, which is double. So you can flip it around and see that double. Whereas at the 50% mark, you're probably expecting it to be a bit wider. In all honesty, I don't know what's going to happen with the textbook exercises, but in an exam, we would make it obviously close or obviously far apart. So if it's 15% difference, then there's an association. If there's 2% difference, there's not. Does that make sense? Good question. And this is the thing about statistics. If you use statistics later on, and maybe like in a media sense or in a sales or marketing sense, you will look at the association, you'll make it sing for you. That's the problem with statistics. You can just look at it and go, oh, that's not quite the number I want. I'll look at it in this way. I want it to look like males and females have got the same attitude to gun control. So I won't do the percentage table. I'll do the 32-30 comparison and you make it sing for you. If you go into a statistical field in terms of psychology or science or something, you might be a little bit more rigorous with your use. And nowadays people are a little bit more accepting to say, I thought this might be happening, but the statistics work against my thoughts, my hypothesis. That's fine. But yeah, you open up a magazine or a newspaper, you'll probably find they're making the statistics work for them. That's why you've got to be able to see that and make the right conclusions. Here's another example which you can have a go at. Researchers wanted to know if Year 10s and Year 12s had differing opinions on whether mobile phones should be banned in schools. What can you gather from the table? So you're going to write this example down in your book, then you may as well write it down and then write down a sentence or two. If you're not writing stuff down in your book, have a think about this, and in a minute or two, we'll determine a sentence that summarises what the explanation from the table is, and we'll go from there. Okay, let's hear a suggestion. Do you think there's an association between these variables? I think I've heard some quiet no's and I've seen a head shake, so that'll do me. So is there an association between these variables? I doubt there is. And at the moment, this comes into your question earlier, Lucas, there's a difference here of 1.1%. So if you told me that I was about to ask a Year 10 student what their thoughts of mobile phones in cinemas were, that wouldn't be able to help me work out which way they would swing. The Year 10, Year 12, there's no difference, therefore there's no association. So we make the statement that no, there's no association, and therefore the explanatory variable does not explain the response variable. In this case, the explanatory variable would be the independent variable, which would be the year group that they're in. Does that explain whether they agree with mobile phones in cinemas or not? No, there's no association. So that should look something like this. In this sample of 100 year blah, 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 we see the percentage of that student support having banned mobile phones in there. indicates the person's support for banning mobile phones is not associated with their year level. So you'll notice here again that we've got the mathematical summary, and this should be the easy bit to do mathematically because it's just stating the facts. And then we've got what this summary means in terms of whether there's an association. So it's a two-part answer. And it's going to be important in general maths. Sometimes you'll get questions that look like you can do them in 2 lines, but they're worth 3 marks. You've got to be considerate of the detail you put in based on the marks they're worth. Otherwise, you might be missing things. Are there any questions on that? Now that you can't read it because I've highlighted it in garish colours? No? Here's another one. Are males and females in Year 9 equally likely to indicate an intention to go to university? Data from interviews with 200 Year 9 students was summarised in the following table. Write a brief report addressing this question and quoting appropriate percentages. So again, I'm going to leave this with you for a second. And again, this would be a good one to actually have a go at and write down. Be a 2-sentence statement. The first sentence will be your percentage analysis with the data, and the second sentence will be a statement about whether there is an association or not. And I'll leave that with you for a couple of minutes. Done. So let's have a quick talk about this. There's the data. You will have 2 sentences in your response. One will be a summary of the data. Do you need those open, Johns? Okay, let's be paying attention then. This is the summary of the data. And the second one will be the overall conclusion. And in the first one, in a sample of 200 Year 9 students, what percentage of males said that they intend to go to university? Did anybody calculate this? 47.6? 47.6 what? Did you do 2 decimal places for me? 6.2, cool. Oop, that's notes on me. 47.62%. And females? 0.84. So in this case, would we say that indicates an association? Give or take, I think I'd probably go towards an association, but only just. And again, part of your swing here, so if it was close, we'd probably accept either as long as you backed it up. But part of your swing here is the question's set up to look like it's about the same, but actually it's a reasonably significant difference in that 10% difference. Because there's a few less females, and that's a little bit higher, the percentage outweighs, and it flicks over that 50% mark. So it's actually a reversal. If I write the percentages in here, we get about 48% and 52%. Here we get 57% and 43%. And so you can see there's that sort of crossover reversal of percentages that indicates a bit of a swap of the genders. Even though it's close, there's a couple of things here that indicate there's some sort of association. And you can put in some descriptive terms to just show that you understand it's not quite as strong as you thought. So you could say it's a weak association between these variables. Yeah, a little bit. Like we'll probably make it obvious. But if it wasn't, if it was close, then we know it's going to be a point. If you back it up reasonably well, and your statistics are right, that's really what we're looking for. Then it's not going to be the end of the world. 10, I'd probably swing at the 5 to 10 mark. Probably 10, I'd definitely say yes. 5, I'd definitely say no. Somewhere in between, I'd be looking at swap over, looking at where we're at, looking at the context a bit more. Last one, and this one just gives you a bit of an understanding. So you won't have to do this. I'll just talk to it very quickly. Gives you a bit of an understanding of how we can include more than 2 variables. So it's quite a hefty table, this one, and this is to do with adults who are asked. They'll ask their level of education, then they'll ask whether they currently smoke, whether they used to, or whether they never have. And that actually, again, this table is quite good because it looks, you take out that one there, these two look quite similar. That one there doesn't have the 30s. These have heaps of 30s. So you look at it across here and go, that's pretty similar. There it varies a little bit, and you can see that change happen here. But that means that it can be a little bit misleading. But we're at a total of 100. So these are already as percentages. So they're already comparable. But because there's 3 variables on the vertical axis and there's 4 variables on the horizontal axis, we've got to be a little careful about how we determine our associations here and what we say. So just running through, here's a diagram that we could use. And so you might see pop up. We would never expect you to draw this, but it might pop up in an exam, a diagram that looks like this. This is just a stacked percentage chart. It only works if you're heading to the same height. So it works perfectly with percentages. It would work perfectly if you surveyed 1,000 people from each group. It's got to stack to the same height though, otherwise it doesn't work. Because it stacks to the same height and then you colour it in, you can see clear association here. You can see that it's lower there and it's working its way up. So the association here, it's important not just to spot the difference, but to see a trend. And in this case, you can see that those stacks are decreasing from the first one to the last in both levels, except for the light blue, which is decreasing from the first to the last. So obviously, because it goes to 100, if one increases, the other has to decrease. But you can make an association call on either of those 2 endpoints, either currently smokes or has never smoked. You can use that as your endpoints. So yeah, just be a bit careful with that data there. If you're looking at the data and you didn't have this diagram, well, 34, 31.7, 26.5, 18.4, there's clearly a decreasing trend here. Here, 30, 35, 43, 54, there's an increasing trend there. And we probably expect this to be, to say, reasonably similar. It's a decreasing trend, but only just. So you can see decreasing trends here and increasing trend there. Again, that shows association. Now, to answer the question that might come up, which has come up before, what level of trend do you need to see to make the association? In this case, we're dealing with 4 pieces of data. If it's increasing across those 4, that's probably enough evidence to make a call on association. It's not enough evidence to talk about whether it's weak or strong yet or anything like that, but you can see some association in this data. And so that's important. So with the report, your feedback might be something like this. In your sample of 500 adults, there's an association between the level of education and smoking status, as a percentage of adults who have never smoked tended to increase with level of education. The rate is lowest at 30% for those with an education level year 9. So again, you'll note here that this report has quoted the data that they've used to make the summary. So the summary is the first sentence, the data is the second sentence this time, but it's the same thing. It's a 2-sentence report with quoted data and a conclusion. So that's 1B. You're going to find that some of the things that you do are going to involve some written responses. So, or maybe you're happy about it. But anyway.